Okay, good day, guys. So, as discussed, I would like to create a short video on this Pandas library, and I'll share this notes or the notebook with you guys so that you can go through it yourself. So, as explained here, Pandas is a popular open source data manipulation and data analysis library for the Python programming language. It provides a powerful and flexible set of tools for working with structured data, making it a fundamental tool for data scientists, analysts, and engineers. Pandas is designed to handle data in various formats such as tabular data, time series data, and more, making it an essential part of the data processing workflow in many industries. So, here are some key features and functionalities of Pandas. We've talked about what Pandas is before. Uh, so, the data structures. Pandas offers two primary data structures. Like we said, it works with data in the form of basically what a spreadsheet is, tabular form. It gives you a very easy way to manipulate those data that are in tabular form. So for Pandas has two data structures. The data can be in data frame and or series. So a data frame is a two-dimensional size mutable and potentially heterogeneous tabular data structure with labeled axes, rows, and columns. Basically, what a table looks like. A series is a one-dimensional labeled array, essentially a single column or row of data. We'll look at this when we are looking at the difference and what they do. So another feature of Pandas is the ability to import and export. You don't just work with the data in the Python library, you can import in a data from different sources. If you have a data in a CSV format, an Excel spreadsheet, an SQL databases, and more, you can import this data, do your analysis and manipulation, and you can as well export this data to any format you like. You know what file extensions are? Basically files that are in, we'll talk about that too. So data merging and joining, those that have done SQL, you know what data merging and joining is. You can combine multiple data frames using methods like merge and join, similar to SQL operations, to create more complex data sets. You have multiple spreadsheets, for instance. So you can, in Pandas, you can use merging and joining to combine these spreadsheets into one data frame. It gives an efficient indexing. Pandas provides efficient indexing and selection methods, allowing you to access specific rows and columns of data quickly. So, custom data structures. You can create custom data structures and manipulate data in ways that suit your specific needs, extending Pandas capabilities. So, Pandas is a very powerful library that gives you the ability to do and undo with your data. Uh, you can create, manipulate, change, delete, add anything you want to your data as long as you're working with it in a Pandas data frame. So, like we've discussed with all libraries, we said most libraries you want to use with Python, you would have to import them, assuming you have them installed in your PC. So after installing Pandas, to install Pandas, if you don't have it when we're doing installing with Miniconda, you run either conda install Pandas or pip install Pandas. So if you run this in your terminal, you'll be able to install Pandas with either one of these package managers. We talk about package managers. You guys, uh, I think it's in week one we talked about package manager and package managers. If you go through it, you should be able to see it again. So when you run in after if you have Pandas installed in your PC, you can run Pandas, but you can import Pandas to that your particular script by running import Pandas and as alias PD. We talked what a PD is. You can always import Pandas the way it is, but we normally use it's common to use an alias for Pandas and as PD. So For that particular script, anywhere you want to use pandas, you don't have to spell out the word pandas. You can just use the word PD. PD will stand for pandas. And like I said, you can change it to whatever you like. You can use as A, as B, but of course, you use something you'll be able to recognize. So running pandas as PD means pandas will now be able to, or pandas is now running on that your particular script, and you can use its features and methods and attributes. So once you've imported pandas, what can you do with that pandas you've imported? Okay, now data loading. Say for instance, you have your data sets from another source, let's say in a CSV format. We keep saying CSV format. What does it mean? I think I've talked about this, but it's basically a file extension that means comma separated values. So you can have it different file format. You know what file format is? If you have a file that is file.pdf, you know that it's a PDF file. You can have a file dot what again? HTML, which is an HTML file. You have a file dot JSON. All these are file extensions, and basically the extension of a file shows you what format that file is. So we have a file dot CSV, which is basically a file that each data entry is separated by a comma. That's what it is. And you can also have a file dot tsv. It's also a form of the CSV, but it means tab separated values. So instead of comma, it's separated by tab. You can have the Excel file dot slsx, I think it's in this format, and so on. And so with pandas, you can actually load any file that is in this format. A lot more. You can even load a file.txt with pandas. You understand? You can load a file you've just saved to a clipboard. So, but for the sake of this particular video, we'll be dealing with loading a file in a CSV format. So how do you do that? So if you want to read the file, in the CSV file into a data frame, with any data you import in, like I keep on mentioning, data that if you have multiple data and you like to store in one single variable, you name that variable and you equate it to that data, like we've done with list. When you have a list of numbers or a list of data that is a combination of different data types, if you want to store it one single variable, you load it to you do that. You can do that. So it's the same with pandas. When you're loading a file into your script, you'll have to store it in a variable. So we've called this variable df, which basically means data frame. And the way you load a file is you call on PD, like we stated. In importing pandas, you gave it an alias PD. So here, if you didn't add this as PD, you would have to spell out the pandas. But for this particular case, since we've imported pandas as PD, we can just call on pandas by saying PD dot. Now, the way to load a CSV file or any file is calling on the read method, but the read, after calling on the read, you would have to identify what is the extension of that file. So it so happens my file is a CSV file. So I will now tell pandas that to read this file, which is a CSV, by saying underscore CSV. Then in the parentheses, you include the name of the path of your file or the name of your file in quotations. So why did I say name or path? We'll look at that as well. So before your pandas or your Python will be able to read the particular file you're trying to read or load into your script, you would have to indicate where that file is located on your PC. You can trace this by going to your Explorer and looking at the path. But normally what you do to make things easy is that particular file should be in the same directory as this your Pandas script. So if it's in the same directory as this Pandas script, this notebook, in the same directory as the notebook you're currently working on, I'm talking about this whole notebook. it means you don't have to add the path and you can just post the name of that file together with its extension in either single or double quotation. Now, this is just an example. I don't have a file called your file.csv. I'm just stating out. That's why you're seeing this error right here. So, but we'll look at how to load the file later on. So, having been done with the loading of a file, let's talk about what a series is. You know, we said Pandas comes in two structures. It can either be a series or a data frame. So basically, a series is a one-dimensional labeled array in Pandas. It can be thought of as a single column of data with labels or indices for each element. You can create a series from various data sources such as lists, NumPy arrays, or dictionaries. So straightforward, you have a list Pandas. You want to create a series from a list, like we've said, is just a single row, a single column, one-dimensional labeled array, which is a single column of data. It has multiple rows, obviously, but just a single column. So you can, if you know what a list is, you know it's going to be easy to create a series from list. So let's say you have a list called data with this data in it, 10, 20, 30, 40, 50. How do you convert it to a series, Pandas series? You can, let's create the variable s, then you can call on pd, then call on the method series. It's basically saying convert, you want to convert something to a series, then you feed it what you're trying to, the data you're trying to convert to a series, which in this case is called data. Obviously, you know, we can call it whatever we like. You can call it my list, and here you can have my list inside the parentheses. So when you run this, you'll be able to see that's this your data in the form of a pandas series. This is the data and this is the index. You know, pandas comes with index. If you don't specify what you want the index to be, it's going to create the index for you. So this is what the index is. So because pandas takes position very serious, so it comes with the index if you don't specify what the index is. So you can actually choose what the word to label this your index with. So if you don't specify, it will come with a position starting from 0 down to whatever the data entry stops at. So, but it's good that I state this now. You can actually specify what your index would be by passing in the argument index is equal to. So we can choose something by creating a list. Let's say A to, sorry, B, B, C, and I think we have four data and five data entry, 1, 2, 3, 4, 5. So yeah, so once you've created this list, you're telling pandas that you want the index should, the label of the index should be from A, B, C, D. So at A, position A, you have 10, position B, you have 20, 30, and so on, so on and so forth. So when you run this, you notice that the index has changed and you have your data in the form of in the position should be, it will be now A, it will now be A, B, C, D, and E. So this is labeling the index. So I think we should create another data with this so that you would understand better. So let's type this here and let's change this to my list 2. Let's remove the index here so that it will come with the default index, and this we can say specifying index with, with a label, or let's say choosing index label. But let's leave it this way. So okay, this will run an error because I haven't included this. Let's run it. Now let's change this to S or P data series. and call on the series. So here you can run it again. So that's that. Mhm. Another way, you don't need to define a variable before you be able to run a pandas series. You can just load in the data like we've done here. We said x is equal to, we're now calling on pandas dot the method series. Then you pass the list directly into this as an argument into the series method. So when you do that, it will just consider passing and creating a series with this data you've added to it. So when you run that, you can have your pandas series. This data you've created will be converted into a pandas series. Like you see here, we saved it to a variable, stored it in a variable called mylist2 before we did that. But here we're just using the data directly into the method called series. So that's how you create a series using a list in pandas. So let's say you have your series. How do you access the data in that series? We've talked about how to access a data. Let's say, you know, we have, where is this thing is? We have a list called my list. Yeah, that has this particular number. So let's assume we want to access the data here called 30. You know how to do that. You just basically use the square bracket and call the position. So what's the position of 30? It's 2. So when you do that, it's going to display the value at position 2, which is 30 for that particular list. So likewise, when it comes to a pandas series, you can do that as well. You can take the position and place it. The name of the series we've created, we converted this my list into a pandas series called S. You can also pass the position that you want, 30, to S, and it will display what's at position 2, which is 30. If you want what's at position 0 of X, not at S this time, this other list, which is 12, 12 is it's at position 0. When you run that, you get your 12. So that's how you access a list uh, using the position. We're going to talk about lock and ilock right now. Basically, ilock lock is accessing a value using the index label, and while ilock is integer location, which means accessing a value using the position, its position, index position. We'll look into that, but for a series, you can either access a value. So like I said, there's what is called lock and ilock. We'll look into that when we're dealing with data frame. But ilock is position-based indexing. So it's basically locating an item in a data type, in a series or a data frame, using its position in that series or data frame. So for in the sake of series, in the case of series rather, sorry, you can use ilock to locate the item in position 3, just like we did with just using indexing. You know why you do this later on. But in position 3, you can use ilock to access by position, and it will show you what is in position 3. Position 0 is the same. The one you don't include the lock is called accessing the element with label. So label based indexing and position based, while ilock is position based indexing. The I stands for integer. So what about if you want to access multiple elements? We've done this too with the list. Say, for instance, we would like to access my list, what you have at position 2, 2, 4. So, in this case, it's going to be what? 30, 40. So it's going to be what is at position 30 and 2, which is 30, and what is at position 3, which is 40, because uh, indexing this way, trying to extract the access what is at a position this way makes that in it's actually exclusive. Like the you can you it won't include the last number in the range. Like we said, from range is basically exclusive. If you say from position 2 to 4, the item at position 4 will not be included. So it's exclusive. It's not inclusive. So likewise, if you're doing it this way, you say you would like to access the items that are in this your series. You can do the same for series from 1 to 4. The item at position 4 is not inclusive. With the range, like we said, the items are at the end of your range are not inclusive. So if you wanted what is at position 4, this would be 5, for instance. So when you run this, it will include what you have at position 4. So, but let's leave it at position, what is at position 4. So uh, this is indexing, accessing multiple elements in a list, in a series rather. So we can do this for what we have X, the other series we have called X, and we'll get what is at position 2 to 3. Position 2 to 3 is basically what is at position 2 because 3 will be exclusive, not inclusive. So that's that for series. There are some attributes and methods in series. Like you can call on the values to see the data you have in that particular series, index to see the labels of that series. You can call on the shape and the rest. We created a series that has labels. I think we created a series with labels here because we set the index to this particular label. So we can call on index to see those labels. So let's do this. So I think the series is called DS. So you can call index on that and it will display the index. So index is an attribute of this series. So there's a difference between series attributes and methods. You can browse that on your own and find the difference on what they mean. So index will basically display the index label of that series. You can use ds.values and this will display the data in that series. These are attributes of the series. You can call on index and ds.shape and this will what display the dimension of the series, the shape. Now basically it's saying you have 5 rows. Series doesn't have multiple columns, so it's showing you the rows you have here. So it's basically 5 rows because it's one dimension. So that's what the methods are. Now, in this attribute, some of the attributes. So you can call on the method like let's use sum and see. So you have ds.sum, which is a method, not an attribute. So maybe you should have noticed that attributes do not come with parentheses after them, but methods do. So you can check the mean, the sum, as long as the data type in it is numerical. So these are the attributes and methods of the series. So we're done with series. Let's talk about the data frame. So data frame is a two-dimensional labeled data structure with columns of potentially different data types. Think of it as a table where each column represents a variable and each row represents an observation or data points. Data frames are suitable for a wide range of data, including structured data from CSV files, Excel spreadsheet, SQL databases, and more. So we've already explained before. So how do you create a data frame from dictionary? We created a series from a list, so you can create a data frame from dictionary. So you know what a dictionary is. You have your key and your value. Normally, a dictionary probably has, you might have known that you can have, let's say, record. You're trying to create a dictionary called record, and you would pass in the key name, pass in a name Abdul to it, and let's create a key called ID and pass it a particular number. So now this is a typical uh, uh what's it called dictionary. So this dictionary is a typical example of a dictionary that has one entry, one value for each key. So let's assume you want it's a collection of students, says a number of students in a class. How do you do that? You pass in the name and you want to pass multiple names. So that's where you need a list like we've done here. It's not just a record of a single student. Let's call this. You want the dictionary to record multiple students and their ID or other information. So you pass a list to it that contains all the names of the students, for instance, or the staff or the customers or whatever. So each key will now be passed a list if you have more than one data to pass to that key, one or one value to pass to that key, like we've done here. So if you have this, let's comment this out. You know, if you comment something out, you're trying to not see it. I would like to view this dictionary called data. When I run this, you can see how it is. You have the names, the age, and the series and the city. But this doesn't look nice. Clearly, you can't make much sense of this. Obviously, you can access any data you want here by calling on the name or the age and passing and looking into particular data in that dictionary, but it doesn't look nice. If you want this in a tabular form, this is where Pandas comes into play in a data frame basically. So if you pass, let's comment this out. If you pass this variable data that stores this dictionary that has this particular information in it into a Pandas method called data frame. You know, the other time as we were trying to convert data into series, we passed data to method called series, but this time we're passing it into a method called data frame. Basically, you are saying PD pandas calling on the data frame method to convert this data you have, this value you have into a data frame. So if it's a valued, if it's a valid value, it's going to be converted into data frame. So once I run this right now, you can see that this is much better. We have let's comment this out and see the difference. So you see, this is the dictionary. This particular line of data is the dictionary, and this is the dictionary converted into a data frame. You see, this is much better. It's much better. So you have your name, your age in a tabular form. So this is a data frame. This is what it looks like. So you can agree with me that it's better. You have three columns: name column, sorry, you have the name column, the age column, and the city column. This 0 to 1, 2, 3, you know, it's the position, it's the index. So this is a typical data frame. So assuming you have multiple columns and it so happens that you want to extract just the name column, you can actually print just the name column, just the city column, or just the age column. Basically what we mean by column selection or slicing the data frame. So you can select a single column from a data frame by specifying the column name within double brackets. Multiple columns can be selected in a similar manner, creating a new data frame. So you have this. You can create a new data frame by just you can select a single column from a data frame by specifying the column name within double brackets. Multiple columns can be selected in a similar manner, creating a data frame. So basically, they're saying from this data frame, you can decide to create a new table that just contains, let's say, the name or the age, name and age, or the city or the age and city, basically subsetting or slicing this data frame into a new data frame. So, for instance, let's print this. You see, this is just extracting the name column, but the way this doesn't look like a data frame. it looks like a series. The reason is because from the description they said by specifying the column within double brackets and you used single bracket. If you try to extract one column and use a single bracket, it's basically you trying to create a series from that column of a data frame, not what do you call it? Another data frame. This is a series. So if you want a data frame, you can you will have to use double brackets to call on that data frame. So this time when you print it, let's call on print. Oh, I didn't close the quotation here. Let's call on print, and this looks better. You can see the column label, and it's telling you you have Alice, Bob, Charlie. This is now a data frame, not a series. This is a series, and this is a data frame. This is a series, and this is a data frame. You can prove that it's a series by calling on print, then passing the type function into this your selection name. Yeah. So when you do this, it's going to still print this what you've printed before, but as well as show you the type of this data. So you can see it's a class Pandas series, right? So, but if you print the type of this one, we used the double brackets for, and double brackets. Okay, I didn't include the type. Let me add the bracket here and type. You'll find out that this is not a series, it's a data frame. So the difference is the number of brackets you used to create to slice that your particular data frame. So this is a data frame. By using double brackets, you are indicating that you are trying to create another table with just this particular column. Now, for that reason, if you try to use single brackets for when you're trying to slice two columns, it won't even work. You would have to use double brackets. If you run it with just single brackets, it will return an error because using a single bracket is like trying to say you're accessing just the data and that's a series. So if you want to access rows, you can access rows by their index using iloc, which is what position based indexing, or by using label based indexing. You can use the label by using iloc. So that's what it is. Now, if you want to use iloc, you know that this is the position 0, 1, 2, 3. So when you call on the data frame and you pass it uh, the iloc argument, you say data frame.iloc, then you pass it the position 2, it will just show you the data that is in position 2. If you go back to Charlie, you have Charlie 35 and the city Lagos. You know this is not the data frame. We just sliced the name and age column here, but you know it's going to include the city. So you have Charlie in position 2. If you try to check what's in position 0, you're going to find out that it's Alice in position 0. So this is extracting what is in that position in the data frame. You can as well pass this into another variable and store it there, but we are just looking at the integer position based index. Now, talking about label based index, as this particular, we've not indicated what our label is for this data frame. Let's display the data frame again down here. Let's do that around here. So it's called df. Let's display the data frame. As you can see, this is the position. We haven't passed any index to it. So we can actually change it by going back to the data frame and indicating that we want the index to be called whatever we want. Let's use the same. How many data entry do we have? It's 4. So let's use our letters this time as the index. So we said if you're passing multiple data values, you're going to have to create a list. So let's do this. So that means when we call on lock this time and you do this, it's going to return an error because you're using a label based data frame, and this time you have a label, not just zeros, one, two, and whatever. So this is not the label of the position. So it's going to return an error. It's saying it doesn't recognize one as a label in this case. But when before we included this index, let's run it. I forgot to run it. Let's remove this index and run it again. Before we included this index, if you run it, you're going to have what is at position 1 because the ilock and the lock will be the same in this case because the label of this index is still 0, 1, 2, 3. Indexing by ilock does not care about what is here. It just would look at the position clearly that this Alice is in position 1. That's why when you import position 0, that's why you use ilock to access Alice. It will show you what is in position 0 regardless of what is here. But if you try to use lock on this particular label, it will have to look at the label. Now that we've not set the labels are 0, 1, 2, 3. So when it looks at that label, to use what is at position 1 and it will work. But when you've changed you've defined the label, this time like I defined it the other time, so let's bring it back. If you define the label, you can print df again and see what the label is. You see our labels are A, B, C, D. You can still call on ilock using the position, which is position based index. You can still call on ilock and pass a label, a position to it, and it will show you what is at that position. But if you're passing on lock, you would have to indicate the label. You want what is at position A. Sorry, I forgot the quotation. Since it's a string, you'll have to use a quotation. So you see, this is the same. ilock would display position 0 because it knows that using a position, it knows that this is 0, position 0. But if you want to use lock, you would have had your labels defined, and we defined it as ABCD, so you can display what's as position A, print df dot lock what is at position C, for instance, and it will show you exactly that. What did I forget? Okay, I used curly brackets here. So it will show you both what is at position A and position C separately. So this is how you use lock and ilock. So slicing is basically the same thing. You can slice data frames by data frames to select specific rows and columns. The way you slice is by calling the names like we've discussed before. You can see it is sliced by columns by calling the names of the column df, then use double brackets and it will display what's at that column. And if you want to slice by rows, you can indicate the position of the rows. You want what's at position 1, 2, 3, and like we've said before, the last number is not inclusive, it's exclusive. So this is how slicing works. Now let's you don't just have to print it, you can actually save it in a data frame called to. For instance, we would like to save what is here into a data frame, another data frame entirely called to. So when you do that, you would have a new data frame saved to your script. So when you call on df2, it contains just the name and the age of your data frame. So it's not as if you're saying you just have to print it. No, you can save that in a new data frame. You can also save this particular df1 to 3 in a new data frame. Let's create a new data frame and call it data frame 3 is equal to, no, this is not what I want. df, then we want what? Yeah, 1 to 3, 1 to 3 rows data in 1 to 3. So when you call on df3 again, this time you'll be able to see just the values in position 1 and 2. Like we said, 3 is exclusive. So finding unique elements in a data frame. So you know In terms of ages, you have a table and a list of students, a record of students. You can have students with the same age. So if it so happens that you would like to see just you would like Pandas to extract just the ages that are unique, basically how many students and ages that are unique in the record you have, like in this case 12, 25, 30, 35, 28. You can have multiple 30s, multiple 25, but you just want to see the unique data in a particular column. You call on that column and you pass the method unique to it. And when you run it, it will show you the unique data in that column as well as the data type, which is the data type of the values in the column, which is integer. So that's how you check on unique. Conditional formatting and filtering. If you would like to filter your data, for instance, to see the age of students that are older than 25, since it's an integer, you can call on the data frame as you're saving it. Let's do it at the top here. You can do this. If you're filtering by age, let's say I'm trying to filter by age, but I want ages that are greater than 25. So it will show you a Boolean because this is just a conditional state, a logical statement or expression. When you introduce equal to or greater than and the rest to a statement, the result of that code is going to be Boolean data. So it's saying if you're looking at the age column that is greater than 25, the first row A does not pass, which means A is less than 25, B is greater than, C is greater than, and D is greater than. So this is a Boolean expression, and it makes sense for just looking at it. But if you would want to make sense, real sense out of this, like look at the data where this is true. You just want a collection of the data where this is true and possibly create a data frame out of it. You would have to subset this condition and place it and say out of this data frame, extract the data that met this condition. The same way we use age in a square bracket, you can actually pass a condition into an argument as an argument into a data frame. So you're saying you want this then the data that pass this condition to be extracted out. So you see it will exclude the A that doesn't pass the condition that is less than 25, and that is not greater than 25, and it will create a data frame of those that are greater than 25. So you have BCD. So here, what happened here is basically another data frame was created and they passed with this data. So if you display the data high above, why I don't know why this is here, so let's remove it. If you display high above, you would see the same thing as this. So it's been saved into another data frame. So it's good practice when you're extracting or when you're slicing a data frame to save them in another data frame so that you can always refer back to your initial data frame and see what's next in case you've made mistakes. So that's that for filtering. This is just a short course. You can browse and we're going to look more into it when we go further. So when you're done with your data frame, let's say you've made all the analysis and you're trying to save this data frame rather, so that you'll be able to view it outside your script. You use another method of Pandas called to CSV or to whatever format you'd like to save it. To save a data frame to a CSV file, use this to CSV method and specify the name with extension.csv. Pandas provides other functions for saving data frames in different formats. So what we are saying is we are trying to save this data frame in CSV format, so it's .csv. If it is in tar format, it's .csv. If it is in SLX format, you can say .slx. But as you're changing it, you'd have to change the name as well because this will be the name of the file, and names will be in the extension has to be included to know what format this before any computer will be able to open a file to have to know what format it is. So, but for the sake of this particular course and video, we're saving our file in a .csv format. So, and we're saying index false. Why are we saying index false? We don't want it to come with this index. We just want our name, age, city, column. If you don't set this index to false, it will include this ABCD or 123 in 0123 if you don't if you indicate it. So once you've saved this, if you remember, I said if you're trying to name a file, you will have to include the path. Where is it located in your system? For instance, if it is in user and let's say downloads, for instance. So, but it so happened that I just want it in the same folder as where this particular file called pandas is located. So I don't have to include a path, so I can just save it like this. And when you run this line of code, that particular data file has been saved as trading.underscore data. So when you go to the folder this pandas is located, you'll be able to find it. So before that, let's look at attributes, or let's go to the folder and see it. No, this is not what I'm trying to do. Come on, come on. Where is it? Let's go to the folder. I think it's on my desktop. 3MTT pandas. Oh, sorry. I was opening. This is not what I'm trying to do. Yes, it's called trading data. If you recall, this is our data. We called it trading data.csv. But obviously, just the name will appear. So it's a CSV. If you read what's at the type, Microsoft Excel comma separated values file. That's the CSV. You can open it with Excel, The CSV file can be opened with Excel. So you can display your data here. And as you can see, we have our name, age, and city columns and the data that is there. Now, as I was saying about the index, if you decide that you would like to leave the index and you run this, let's refresh this, your data would come with the index ABCD. As you can see here, you have ABCD. This doesn't look nice because you might need to remove it, but in case you still need it, you can leave it. But if you include that argument, index is equals to false, and you go back to your data and you run it again, so you can see that we don't have the index again. So that's how you save a data. So data frame also has its own attributes, just like series we've seen before. It also has shape, info, describe. It has the values, it has the index, apply, and you can look into it yourself when I share this with you guys. So that's all for our class. Let's meet with you guys in the next physical class so that we can look further into pandas. And I would also create a video on NumPy as well, but you should make do with this one for now. Yeah, so goodbye.